pencil sharpener versus a
Faster.
normal one when you use an electric pen?
Nothing. Okay, so 10B. So the more of those questions that you do where you are building up those equations, you'll start to realize that they are quite similar and that relate to physics formulas, and you'll be tempted, but you will not shortcut because you know you need to show you're working out. However, there's a whole bunch of formulas here on this page. You don't need to memorize these. I think a couple of them might be on your formula sheet, like the velocity ones are, but most of them are not on your formula sheet. You don't need to memorize them though. If they give you one of these formulas, you're allowed to use them. If they don't, you have to derive them yourself. Okay, so the theory in this exercise is to show how we can get some of these equations, and we will be using the velocity equations, for example, to show how we get some other ones. So let's have a look.
Miss, would you be able to work out the flight path of one if you knew the drag coefficient and you took that away?
Can you?
Force?
Can you? Have you done that in physics?
No.
Yeah.
We don't do friction.
I don't know that I've ever tried. Okay, so question, it's not really a question, it's more of a derivation. It says a Cartesian equation of motion. To find a Cartesian equation of motion, which means we want to know the equation of that projectile in terms of x and y. We want to eliminate the t as a variable because the t is our parameter. Yes?
It's studying stuff instead of like.
Okay, I'll just continue. So it says that we're going to use the horizontal and vertical displacements and we're going to solve them simultaneously. I'm not going to derive those again. They're on that other page. The horizontal displacement is x equals vt cos theta. That's straight out of that table. And the y is negative g, that's for gravity, t squared over 2. The reason they use g instead of a number is because, as you have seen already, they use different numbers for gravity depending on the question. Plus v, which stands for velocity, p sine theta. Now, to solve these simultaneously, I'm going to have to sub one into the other, and I want to eliminate the t, which means I want to get t by itself. The first equation is going to be the easiest one to do that. So let's get t equals x divided by v cos theta. That's going to be my equation 1. This one over here is my equation 2. And I'm going to sub equation 1 into equation 2. So following equation 2, we have y equals minus g and t, which is x over v cos theta squared. So that's my gt squared over 2. I'm just going to put the g over 2 out the front of that other fraction, okay? Plus vt, replace the t with x over v cos theta sine theta. Okay, I've subbed it in. Let's do some simplifying. Squaring the bracket means I square the x and I square the v and the cos. So I have minus gx squared on the top and 2v squared cos squared theta on the bottom. I push the two fractions together. Plus the v out the front and the v on the bottom can cancel. So I will just have the x and the cos theta in the bracket, but the sine theta over the cos theta makes tan theta. So I can write that as x tan theta. We're trying to get this to be the one in the table over here. Where is it? This one, the equation of path, that big long one there. And see how it's in terms of tan? which means I have to get rid of that sec squared, the cos squared. But remember, it's 1 over cos squared, which is sec squared, and I can use that same Pythagorean identity to try and change that into tan squared. So that is minus gx squared over 2v squared. The cos squared is sec squared theta on the side. And then on the next line, do you remember what sec squared is equal to in terms of tan?
Tan squared theta plus 1.
Yes. It cancelled. In the second term, it cancelled.
Oh, yeah.
So it's either 1 plus tan squared or tan squared plus 1. And there we go. I've taken the two displacement equations, I've subbed one into the other, and I came up with that amazing equation that you want to memorize for the Cartesian equation for the path of motion. Yeah? So all you would need to know is what gravity constant do you want to use, what's my angle, and what's my initial velocity. If you sub those in, you would have your equation for your parabola. All right, that's what that would mean. All right, what do we want to derive next? Next one, time of flight. A projectile finishes its flight when it reaches the ground. To find the formula for the time of flight, we consider the vertical displacement, the y direction, and we make it equal to 0. That's what we've been doing. We did that in those other questions. So, in the table, I'm not going to derive the starting equation, but in the table, it said that y was equal to negative g, we've used this equation already, t squared over 2 plus vt sine theta. Okay, that's my equation for y. I want to put in that y is equal to 0 because that's when it hits the ground. That's 0 equals minus gt squared over 2 plus vt sine theta. I'm going to factorize the t. Don't divide it because technically you lose a solution when you do that. So if I factorize the t out, I get negative gt over 2 plus v sine theta. Now, that is factorized, which means either the t equals 0, which is one you should always expect, because at time equals 0, it's at ground level, it goes up, and it's the second one, which is going to tell me when it lands. So for this second one, I have the minus gt over 2 plus v sine theta. I want to find out the time of flight, so I'm trying to get the t by itself. So let's move the gt over 2 to make it positive. So that would equal v sine theta. Times the 2 over. I'm going to be a bit slack and do it like that. Is that all right? And then t is equal to 2v sine theta all over g. So if you're allowed to use formulas, which you're not, sorry. If you're allowed to use formulas, all you need to know is what gravity, what angle, and what velocity, and that would tell you how long the time of flight is across that whole motion. Next one. Nope, not ready. Quick, Ashton, quick. You have to ask Mr. McLean that one. I don't think so. He wants you to use his the physics formulas. Yeah. Ask him that. So for maths, you cannot use the physics formulas, you have to derive them. But I'm not sure about the physics, whether they will allow you to use calculus and this stuff to do it. You have to ask him, I'm not sure. All right, we ready, Ashton? You got it. Okay. Next one, the maximum range. Now, the wording. Range is talking about y values, like domain and range. Range should be y values. But when you're talking about maximum range, it's talking about how far it's going horizontally when you're talking about projectiles. Just to clarify, make sure you don't get that confused. Okay? So, to find the maximum range, we want the horizontal displacement. We're going to substitute that x is equal to r, because in that table of formulas, r was the letter they used for range. Okay? And that y is equal to 0. So let's take our equations, our x equation and our y equation. We're starting with these ones a lot, because from them, everything else comes. Now, it says, first of all, that x is going to be equal to r, because that's going to be the range of our motion. So we're just going to change that equation to be r equals vt cos theta. That's all we're doing for that equation. That's going to be equation 1. In the second equation, we know that when it lands, we know that y is equal to 0. So we're putting that into our equation again. So y0 equals, and we did this before, so I'm even going to factorize out the t as well, like we did before. Okay, and from that, you remember that I'm not doing the working out again, we did this on the last question. We got t was equal to 2v sine theta over g. So if I know that I have an equation over here, equation 2, which is my equation for time, I can sub it into my equation number 1 to find an expression for my range. So sub 2 into 1. That will be range equals v. The t is 2v sine theta over g, and then that's times by a cos theta. Okay, let's put the top all together. We have a 2, we have v times v, so we have v squared, and then we have a sine theta cos theta all over g. That is tempting to think is our answer, but we can simplify it further. Does that, and that look familiar to anybody? That is one of our double angle rules, which means we can bring the v squared, and the 2 sine theta cos theta is the same as sine 2 theta over g. Okay, done. And that's the formula in the book, in the grid. Greatest height. The highest point of the path of the projectile will occur when the vertical velocity is 0. So we make the y dot equals 0. Rearrange this result to find t, and then substitute this value into the vertical displacement to see how high it goes. That's exactly what we're doing with the number problems. Now we're going to do it with our equations so that we can get a rule, right? So we start with our velocity in the y, which was minus gt plus v sine theta. We're going to make the velocity equal to 0, and I'm going to move that negative gt across, so become a positive gt equals v sine theta. Get the t by itself, and I have v sine theta over g. Okay, number 1. Then it said to substitute that into the vertical displacement, which is the y equation. So the y equation was minus gt squared over 2 plus vt sine theta. Okay, they're the two equations. Sub 1 into 2. Okay, so y equals, we're just replacing the t. So we have minus g over 2. I'm going to put the t squared next to it, which will be, can I square it at the same time? V squared sine squared theta over g squared. Okay, I just squared everything inside because I had to square it. Plus v, t is v sine theta. Oh no, press the button again, come back. V sine theta over g times by another sine theta. Okay, simplifying. What can we do? See how I have a negative g and a g squared on the bottom? Let me see if I can get my red pen here. I'm going to cancel that G with one of those. So I'll have a G on the bottom. And I think that's all I can do for the first term. So that's going to be a negative V squared sine squared theta over 2G. The second term, V times V makes V squared, and sine times sine makes sine squared theta all over G. Again, that is almost our answer. And if you look on that table, you can see it's not quite where we need it to be. I need to get a common denominator so I can push those two fractions together. So if I wanted 2G on the bottom, put a 2 on the top as well. And then when I push them together, the top two things are actually like terms. Can you see that? They both have a V squared sine squared. So a minus V squared sine squared plus 2V squared sine squared will be 1V squared sine squared theta over 2G. And that is the equation for the greatest range of our projectile. Yes, common denominator, so I can push them together. Yes. Okay, we are almost there. We're doing all right. Okay, so the last question is not really deriving one of the formulas in our table, but we're trying to show another property. This is a bit of a quirky question, this one. Okay, this is an interesting one. Oh, Ashton, hurry up. Quick.
Oh, okay.
Yeah. All right, I'll read the question while Ashton's still writing. Maybe I can squeeze the question down here. This is still see. Okay. So it says arrange y equals negative gx squared over 2v squared bracket 1 plus tan squared theta bracket plus x tan theta. That was one of our formulas, right? We want to arrange that as a quadratic in terms of tan theta, and hence show that with a given initial speed of v and a variable theta of elevation, a projectile can be fired through the point xy. Can I move it now? Oh, thank you. If and only if 2v squared gy is less than or equal to, I told you it was a good question, v to the power of 4 minus g squared x squared. Okay. It looks, just looking at it, you go, oh my goodness. Can I finish this first? And we'll get to that after. All right. Okay, so it does tell us how to start. Okay, it tells us that I want to make my equation all in terms of tan theta. Okay, so it is going to be a quadratic. The first thing I would do is get rid of the 2v squared that's on the denominator there so that I don't have any fractions. Okay, so I'm going to multiply that out. That means I multiply it to the y, so it would be 2v squared y on the left side minus gx squared, because I've times the denominator away, bracket 1 plus tan theta. But because I have this extra term on the end, I have to multiply it by the 2v squared as well. So it's going to be a 2v squared x tan theta. So each thing has been multiplied by the 2v squared. Did I forget a squared? Yeah, there's a squared. Thank you. There's a squared there. Thank you. Okay, let's expand that out and we'll hopefully get our quadratic. 2v squared y equals minus gx squared minus gx squared tan squared theta plus 2v squared x tan theta. I know it sounds like a lot, but I'm rewriting a lot of it. All I did was expand. The tan squared, that's going to be my front term of my quadratic. I need it positive. So let's move it to the other side. It will be a positive gx squared tan squared theta. Then I want my tan term next. I'm going to have to move it to the left as well because I want them all on the same side. So it will be a negative 2vx tan theta.
Isn't it B squared?
Yes, b squared. I wrote b squared. Did I not say b squared? Then I want my two constants. I had a 2v squared y already on the left, and I'm going to have to plus the gx squared across the other side so that everything is now on the left and it's equal to 0. Now these things on the end, I keep bumping that, sorry. These things on the end, that's just a constant. Okay, in terms of theta, if theta is my pronumeral, that stuff on the end doesn't have any thetas in it, so that's the constant. The tan squared, actually I'll highlight it for you. Here's my quadratic, there's my tan squared, tan, and then the bracket is the constant. So the coefficients, this is gonna be, well, red pen now, that's gonna be my A, that stuff there is gonna be my B, and that whole thing there is gonna be my C in the quadratic. Now, I'm not going to put that in the quadratic formula. What I'm going to do is I'm going to put it in the discriminant because I'm trying to show that the possible values for solutions for theta. And theta is only going to exist if the discriminant is larger than or equal to 0. Okay, if it's equal to 0, it means I have one possible solution, or greater than 0 means I have two. It just can't be less than 0 because that means that there's no possible solution, right? So I'm going to say that my solutions exist when my discriminant is greater than or equal to 0. So not the full quadratic formula, just the b squared minus 4ac needs to be greater than or equal to 0. And hopefully you're going, yes, that's where my inequality sign comes in. Because remember that inequality back in the question? Okay, all right, so let's sub in all that stuff. So, yep, we'll get there. Yeah, where the 2v squared gy is less than or equal to that part with the inequality in it. Okay, so let's sub in. B is the negative 2v squared x, so that's going to be in brackets. Negative 2v squared x is squared minus 4 times a, which is gx squared, and c, that's not so nice, that's the 2v squared y plus gx squared is greater than or equal to 0. This is the problem with being left-handed. All the stuff on the right, on the left, I keep bumping on my screen. I am. Okay, so let's square that bracket. That becomes a 4v to the power of 4x squared. That's just the bracket. Then I'm going to multiply that 4gx squared into the bracket. That will make a negative 8. What order should we put them in? G, x squared, v squared, y. That's not in alphabetical order. You can put it in alphabetical if you want to. I just did it in order on the page. Then minus 4 g squared x to the power of 4. It's messy, but it's just basic algebra. We're just expanding stuff. Okay, I can take out a common factor from those three terms.
X squared.
There's a 4 and there's an x squared. Very good in everything. That will leave me with a v to the 4, a minus 2 gv squared y, and a minus g squared x squared. Now, although we don't normally do it, that x squared out the front, if we can divide by that as long as x is not equal to 0. Okay, so if I divide by the 4x squared as long as x does not equal to 0. Okay, which, you know, if x is the distance that it's going horizontally, we really hope that it's going somewhere. So that's a pretty good assumption. So that just gets rid of the bracket. We also know that we're dividing by a positive there, by the way, because x, no matter what x is a positive. The 4 is a positive because that's an inequality. You want to be careful about dividing by a negative. Okay, so we are trying to get, looking back at the question that you can't see at the top there, we need to get the 2v squared gy by itself, and that's one of the terms. So this here, this 2gv squared y, I want that by itself. So let's move it to the other side. So that will be v to the 4 minus g squared x squared. I'm doing this in 2 steps because the inequality is greater than 2gv v squared y. And then if I want that on the left, which I do because that's what the question had, I turn the inequality the other way, and there's my v to the 4 minus g squared x squared. Because it asked me to. Well, yeah, not really. Not. It's not very practical for us, that's for sure. If that's what you're trying to say. There's the second part. Yeah. It's one of those provey kind of questions. It's like show that you can prove this result and get this result. It's always equal to that. All right, part B then. What does this mean geometrically? Because that's going to be way more practical. Let's get from that equation that we've just got there, let's leave the y where it is and move the other stuff away. Gravity is, well, we usually use 9.8, so we usually put a positive number in there until we do it with vectors or 10. The velocity is squared, that's going to be positive as well. So we're dividing by a positive number, just checking that. So if I leave the y less than or equal to, I have v to the power of 4 minus g squared x squared over 2 g v squared. And you can even split that to be the two terms. So if you put the minus g squared x squared over the 2gv squared, and then the plus v to the 4 over 2gv squared, and that formula there is one of your results. It's saying that your y value is always less than, I think that was your range formula, maximum range. Yeah, cancel now. So the g's cancel out to get minus g over 2v x squared, I think was the way it was written on the formulas, plus v squared over 2g.